Welcome to this video series, and in this video we are going to discuss about jet propulsion. We are going to discuss only about the introduction about jet propulsion as per the syllabus for your scheme, and what are the different types of jet propulsion and how it works. And I am going to explain the working principle of jet propulsion through some video which I have downloaded from YouTube. Always I prefer YouTube for my knowledge development. YouTube is a source where we can get a lot of things, but if you utilize it properly, it will definitely help us and grow further. Now before going further, we will start discussing about jet propulsion. Jet propulsion is nothing but the movement of object in one particular direction is based on the thrust force generated by the fluid which moves in the opposite direction of the system moves. This complete principle works based on the Newton's third law, that is, for every action there is a equal and opposite reaction. That law is the backbone for all jet engine which are working now. And the two general types of jet propulsion are air breathing and non-air breathing engines. When we are using oxygen from the atmosphere to burn the fuel in the combustion chamber, then those type of engines are called as air breathing engines. The moment the term jet is generally used, with the moment you see the jet in the term, it is explained air breathing engine. It includes turbojet, turboprop, ramjet and pulse jet. And let us discuss about the turbo engine or jet propulsion. How does it works? The working of jet propulsion in the next video. That video gives clarity about how jet propulsion works out.
Most jet-propelled airplanes use a turbofan design. The turbofan can be thought of as a high-tech propeller inside of a duct called a diffuser, driven by a gas generator. The core. The core of a jet engine is a gas generator that creates high-pressure gas to power a turbine. This setup has compressor, combustor, and turbine sections. The compressor. Compressed air makes for a much more powerful combustion reaction relative to engine size. Compression happens in stages that force incoming air into an increasingly narrow chamber. A single compressor stage is comprised of a spinning rotor paired with a ring of stationary stator vanes which are attached to the core casing. Rotor blades swirl the air as they force it through the compressor. Stator vanes slow this swirling momentum in exchange for increased air pressure. The compressor has 4 low pressure and 10 high pressure stages. The combustor. Air is mixed with fuel and ignited as it passes through the combustor, releasing a jet of super high powered gas. The design shown here is an annular combustor, meaning ring shaped. Compressed air enters the inlet nozzles. Each nozzle is coupled with a fuel injector and is designed to swirl the incoming fuel and air for an even mix. A couple of igniter plugs, not unlike the spark plugs found in car engines, ignite this mixture and the reaction spreads evenly around the ring. Once started, combustion continues as long as air and fuel are supplied. The turbine. Turbines at the rear of the jet engine are powered by exhaust gases exiting the combustor. Much of the turbine power is used to turn the fan, while a smaller percentage powers the compressor stages. Turbine fins get extremely hot. Some air from the compressor is diverted for cooling, and special coatings are used to keep temperatures down. The exhaust cone is specially shaped to mix and accelerate exhaust streams. It also covers sensitive internal engine parts. The fan. Early jet engines were turbojets, where all incoming air flows through the core. Most modern winged aircraft engines are turbofans, where only a fraction of air enters the core or gas generator, and the resulting power turns a specially designed fan. Again, the fan can be thought of as a high-tech propeller inside of a duct. Air that does not enter the core is called bypass air. High bypass engines are designed to move large quantities of air at slower cruising speeds, a range of about 310 to 620 miles per hour. The exchange for high efficiency is engine size. High bypass engines can be very large, with massive fans compared to core size. Commercial airliners or military transport aircraft are example applications. Exhaust velocity is a major factor in jet engine noise. High bypass engines surround fast-moving core exhaust with large quantities of slower-moving bypass air for quieter operation. Military fighter aircraft use low bypass engines, which are more compact, have high power-to-weight ratios, plus supersonic and afterburner capabilities, in exchange for things like poor noise control and high fuel consumption. Afterburner. High-performance engines may have afterburner capability. Additional fuel is sprayed into a jet pipe section where it mixes with exhaust gas and is ignited, producing a second stage of combustion. Since afterburner is fuel inefficient, it's generally used in short bursts during takeoff, climb, or combat maneuvers. The exhaust nozzle is adjustable for maximum exhaust acceleration and to avoid undesirable back pressure, which can harm forward engine parts.
Hope that video might have given explanation about how turbojet engine or jet propulsion works. Now let us see how turbo propeller works. The following video will explain how turbo propeller works, and it also clarify given a clear understanding how the concept of thrust generation in the turbojet engine. Let us watch a video first. After this we will discuss further.
First, let's take a look at the different types of gas turbine engines which can be installed on an aircraft. We can have turbojet, turbofan, turboprop, and turboshaft engines. In this video, we will look at turboprop engines as shown on this aircraft. We will see how the thrust is created, the basic construction of a turboprop engine, and why they are used on smaller, short-range aircraft. First, let's see the principle of thrust generation on a turbofan engine and a turboprop engine. If we apply Newton's second law, the thrust force is equal to the mass of air entering the engine multiplied by the acceleration. Now, if we consider a turbofan engine, a small mass or quantity of air enters the engine, which is accelerated to a much higher value inside the engine, causing an increase in the thrust force. If we consider a turboprop aircraft, we have a propeller which creates the thrust. Here, a large quantity of air or mass of air is accelerated by a small value, which causes an increase in the thrust force. So in a turbofan, the thrust can be increased by increasing the acceleration of air. But in a turboprop, there is a limitation on the mass of air being accelerated, so it produces lesser thrust. Now let's look at the construction of a turboprop engine. The turboprop engine can be divided into two major sections: the engine core, which is similar to a gas turbine engine, and a propeller which is connected to a turbine-driven shaft. Let's look at these sections in more detail. The engine core. This consists of a compressor which is used to compress the air or to increase the pressure of the air before they are sent for combustion. Then we have the combustor, which consists of fuel nozzles, igniters and combustion chambers. Here, fuel is sprayed, which mixes with the high pressure air and gets burnt inside the combustion chamber. In the combustion chamber, the pressure and the temperature of the gases increase. The high pressure gases are then allowed to expand in the turbine section, which causes the turbine to rotate. This will cause the compressors to rotate. These components are similar to a gas turbine engine. On a turboprop engine, there is an additional turbine called as the drive turbine. Here, the gases expand further, causing a decrease in the pressure and the rotation of the turbine. This turbine extracts almost all the pressure energy from the incoming gases, so very little thrust is generated at the exhaust. This turbine rotates at a very high speed, so it cannot be connected directly to the propeller, as this will cause the blades to stall. So the turbine is connected to a reduction gearbox. This reduces the speed of the shaft, so the propeller operates more efficiently. Now we will look at the propeller section. The propeller consists of a series of airfoil-shaped blades connected to a hub and assembled on a shaft coming from the reduction gearbox. In modern turboprop aircraft, the blade angles will vary depending on the throttle setting. There are different blade angles for different settings, such as ground idle, feather, power, flight idle, and reverse. Now let's see how the thrust force is created on this engine. As the drive turbine rotates, it extracts most of the energy from the high pressure gases, so very little thrust is created at the exhaust. The drive turbine rotates the propeller, which creates most of the thrust force on this aircraft. Approximately 80% of the total thrust is created by the propellers, and 20% of the total thrust is created by the exhaust gases. Now let's do a simple comparison between aircrafts having turboprop engines and aircrafts having turbofan engines. On a turboprop, since most of the thrust is created by the propellers, the turboprop engines are more efficient when operated at lower altitudes, where the density of air is more when compared to higher altitudes. The thrust created by a turboprop is lesser than the turbofan engine, so the aircraft speeds are slower. Aircrafts with turboprop engine can take off and land on a smaller runway. But the biggest advantage of a turboprop is that the fuel consumption is much less when operated on short routes. This means less operating cost for the company. So the turboprop aircrafts can be found on smaller, short-range aircraft, as they are most efficient for these kind of operations.
I hope guys you might have understand the concept behind turbojet, jet propulsion, and the concept behind thrust generation in the jet propulsion system. That is the end of this video and end of this module as well. In the next video, we will discuss about reciprocating compressor, which is another interesting topic to discuss. Till we meet, take care, bye bye, and be safe.